Hi, folks. Topic of the day is density. Most people kind of have a general, conceptual understanding of which materials are dense and which aren't. For instance, a lot of people would say, well, lead, that's really dense stuff, or styrofoam, that's not very dense stuff. But what does it actually mean? So, if you're looking for a technical definition, it's the mass per unit volume of a substance. So it's basically how much mass something has for its size, because volume is how big it is, and mass is how much stuff is really in it. So, some substances like lead, they have a lot of stuff crammed into a fairly small volume. Some substances like styrofoam have a pretty small mass, not that much stuff is crammed into each unit volume of the substance. It's not very heavy for its size. The units that we typically always in here anyways measure density in will be grams per, you say that little slash is per cubic centimeter. Another way to say this though is grams for every cubic centimeter. So if something has a lot of grams of matter for every cubic centimeter of volume, it has a high density. Good example, this is straight out of the table that's in your textbook actually. Copper. Copper has 8.9 grams of material for every cubic centimeter of it. So that means if I had, let's say, one little cubic centimeter of copper, so this would be a little cube that's 1 by 1 by 1 centimeter. That little cube right there would have a mass of 8.9 grams because it is 1 cubic centimeter of copper. Figuring out something's density is as simple as dividing its mass by its volume. So, go back to our example here. If I had a 1 cubic centimeter chunk of copper, it would have a density of 8.9 grams if I put it on an electronic balance. So its density would be 8.9 grams, that's the mass, divided by 1 cubic centimeter. So we would say its density is 8.9 grams per cubic centimeter, or 8.9 grams for every cubic centimeter. Usually you see, instead of writing the words out, D equals M over V. That's usually how you see it written. And finally, density is a characteristic property of a substance. So what does this mean, characteristic property? Well, if something is a characteristic property, that means all pieces of that material in the universe would share that same value, that same property. So, for instance, go back to our example of copper here. Every single piece of copper in the world, regardless of how big it is going to have this same density. Let me explain how that's possible. It doesn't seem like it's possible. Let's say you had your little 1 cubic centimeter of copper. So this is 1 by 1 by 1 centimeter. And it would have a mass of 8.9 grams. It's 1 cubic centimeter of volume, it's 8.9 grams of mass. Well, what if you had a bigger piece of copper? So for instance, what if you had a piece of copper that were twice the size? I'm not an artist. So you got 1 centimeter wide, 1 centimeter high, but this one is 2 centimeters deep. Well, this would have a volume of 2 cubic centimeters. It's exactly twice the size of this one. But its mass would also be bigger. How big would it be? Well, it stands to reason if it's twice as large, it would have twice as much mass. So that would be 17.8 grams. Well, it's got a bigger mass, but it's also got a bigger volume. Go back to our equation. 17.8 grams divided by 2 cubic centimeters gives you 8.9 grams for every cubic centimeter. So it doesn't matter how big the piece of copper is, you guys. If you take its mass and divide it by its volume, as long as it's copper, you're going to get 8.9 every time, whether you're dealing with nice even volumes like this or not. That's why it's a characteristic property of copper to have 8.9 grams per cubic centimeter. It's a characteristic property of any substance to have a certain density. All samples of water, for instance, will have a density of 1 gram per cubic centimeter. Doesn't matter how big the sample is, doesn't matter how small it is. If you divide its mass by its volume, you're always going to get the same value. Now, we'll come back to these ideas. A couple of examples that we could work through here. So let's say you want to find a density if you know an object's mass and its volume. So you got 27 cubic centimeter block of aluminum. You should probably identify these things as you encounter them. If you're seeing that something is measured in cubic centimeters, that must mean its volume is 27.0 cubic centimeters. So whenever you see a number, kind of come back to it and make a little table. It has a mass of 72.9 grams. What is the density? So that's what you're being asked to find. What is the density? Want to find that? Well, go back to our equation. Density is mass divided by volume. In this case, it would be 72.9 grams divided by 27.0 cubic centimeters. Calculator says 2.7. Now, we have to round things correctly based on significant digits here. So this is a division. I know that the numerator has 3 sig digs. The denominator has 3 sig digs. That 0 is significant because it follows a decimal. It's at the end of it's at the end of a number and there's a decimal in it. So 3 here, 3 here. My answer's got to have 3. But my answer only has 2, the way the calculator has stated it. You're getting a glare there. You probably can't see that. There we go. 2.7 only has 2. So how do we give ourselves a third digit of accuracy? Tack a 0 on there for the same reason. That 0 was significant. This one is significant. It's at the end of a number, and the zeros at the end of a number are significant if there's a decimal. All right, another example here. Lead has a density of 11.3 grams for every cubic centimeter. Write that down. What mass of lead? What mass? So we must be looking for mass here. Would have a volume of 122.0 cubic centimeters. So this is the volume. Write that down. Excuse me. So there's a couple of ways we could do this. I want to show you just using the equation how you could do this, and then I'm going to show you a way if you don't like using the equations because maybe you're not so confident in your algebra skills. I'll show you a different way you can do this. First off, the equation way. This is probably what you're used to. We want to find mass. However, the formula is really not set up to solve for mass. Right now it's set up to solve for density. So I'd have to do a little bit of moving stuff around here. I want to isolate this in the numerator here, the mass. So in order to do that, I'm going to times each side by V. The V's cancel. So my equation is volume times density equals mass. So now I can put in my volume, my density, and I can end up getting my mass. So my volume was 122.0 cubic centimeters. My density is 11.3 grams per cubic centimeter, grams for every cubic centimeter, if you will. Now a good check for yourself. The unit you don't want should cancel. We want to end up with a mass, and we know masses are measured in grams, so the cubic centimeters cancels. The math says 122.0 times 11.3. Which is 1,378.6. But that's not rounded properly. So, how many significant digits can we keep? We got 4 here. That has 4 sig digs. We got 3 here. That has 3 sig digs. We can only keep 3. So, I'm going to start counting from this side of the number and find my third significant digit. That one's significant. That's number 1, 2, 3. I have to round right here. Now, common mistake. You might look at this and say, well, it's a 7. It's followed by an 8, so that gets bumped up to an 8. Answer must be 138. No. This is the tens place, you guys. I'm rounding off to the nearest 10. Like, imagine if this were your bank account and your bank rounded things off every month for you just to keep life simple. What if they rounded off $1,378.60 to $138? You'd probably have a bone to pick with them. So I'm rounding off to the nearest tens place. Question is this closer to 1,380 or 1,370? Since it's the 7's followed by an 8, this is closer to 1,380. That's the correct way to round this off. 1,380 grams. That's a good answer. I told you I'd give you another way if you didn't like doing this algebraic manipulation up here. Let me show you. This density, you guys, it's almost like a conversion factor, if you will. What this is saying is there's 11.3 grams of lead for every cubic centimeters of lead. So if I just simply write my volume here that I want to turn into a mass, I've got to use this as a conversion factor. So I could kind of think about this conversion factor in one of two ways. I could say there's 11.3 grams of lead for every cubic centimeter of lead, or I could say for every cubic centimeter of lead, there's 11.3 grams of lead. So I can multiply by this density, but I can flip it based on what I want to do with it. Now, I want to get rid of cubic centimeters. So I want to have cubic centimeters down here as a unit. So I'm going to put the cubic centimeter part of the density at the bottom. And I'm going to put 11.3 grams at the top. And I know to do that because the cubic centimeters cancels and leaves me with grams. And that would give me my mass. So I didn't even really use an equation to do this. I kind of let the units guide my thinking here. We already went over the answer. It's going to round to 1,380 grams. Okay. So if you don't want to remember the equation, you can kind of think, all right, I have a volume. It's measured in cubic centimeters. I want cubic centimeters to cancel and give me grams. That's one way to do it if you don't want to remember the equation. I'll give you another example. Okay, let's say you want to find the volume from the density and the mass. So methyl alcohol, that's a liquid, has a density of 0.79 grams for every cubic centimeter. So the density is 0.79 grams for every cubic centimeter. What is the volume of a 35.0 gram sample of the liquid? Well, that is measured in grams. That must be the mass. First off, equation style. D equals M over V. Well, I need V. This is where people get turned around because V is actually in the denominator. I can't just move the M over here and solve for V that way because V is in the denominator. I need V to be in the numerator all by itself in order to solve for it. I have to isolate V in the numerator. So first thing I'm going to do here is multiply each side by V. The V's cancel. That leaves me with volume times density is mass. That's the equation, if you remember, that we just used on the last page there. Well, I want to get volume by itself. It's got density with it now. I did get volume in the numerator. It's no longer in the denominator, but it's not by itself. It's not isolated. So I'd have to divide each side by density. So I'm at V times D equals M right now. Divide out by density. Now density cancels over here. Volume equals mass over density. So if I plug in my values, my mass is 35.0 grams. My density is 0.79 grams for every cubic centimeter. That turns out to be 44.303 79 blah blah blah. And what would the units be? Well, grams divided by grams cancels. Now I got 1 over cubic centimeters for units. So this is like a denominator in a denominator. So that flips up to the top. The units do work, but it's not rounded appropriately. 35.0 has 3 significant digits. 0.79 has 2 significant digits. Why doesn't the 0 count? Because it's a leading 0. Remember, leading zeros are just placeholders. If I omitted that 0, it wouldn't change the measurement whatsoever. So I can only keep 2 in my answer because 2 is the least that went into the calculation. Here's where I got to round it. That's the second significant digit, 1, 2. So volume equals 44. I'm rounding at the ones place. This is not a 5 or higher, so that's going to stay right where it is. 44 cubic centimeters of volume. Now, what if you're not into this? Because this is tricky for a lot of people. Now, let me show you how you can use this density as like a conversion factor. I know I have 35.0 grams of this alcohol. I want to turn it into cubic centimeters of this alcohol. Remember, there's 2 ways to think of this. I can think of it as 0.79 grams for every cubic centimeter, or I can say, well, flip side of that is every cubic centimeter of this stuff would have 0.79 grams. Well, should I leave it like this or should I flip it? Let the units kind of guide you. I got grams here. I want that to cancel. That means I'm going to want grams here. So I'm going to take this part, 0.79 grams, and I'm going to put it down there. And I'm going to put my 1 cubic centimeter up here. Grams cancel. Cubic centimeter is all that's left. Now look at the math. 35.0 times 1 is 35.0 divided by 0.79. It's the exact same thing I ended up doing here after all that algebraic manipulation. And like we already know, the answer is going to round to 44 cubic centimeters. So kind of a neat trick. If you're not into this stuff, if you're not into that, you can always kind of use this density as a conversion factor and flip it if necessary to let the units cancel and give you the unit that you want to have. Hopefully this helps you guys out.